right. I think in the interest of time, I'll just get started and people will trickle in eventually. So welcome to Advanced React. A little shorter than planned, but we're going to go through just some more interesting use cases and some more interesting patterns that you can see when you're building your own React apps. So for this workshop, we're going to be looking at dog generator, which is objectively the best repository you will ever download. If you want to follow along, but you don't need to, feel free to go to weblab.to/doggen. And again, objectively the best repository you could ever download. So one particularly interesting pattern in React that I wanted to show you guys was the children prop. So you may have noticed that all the components that we've written so far in this class, they're all like empty. They don't contain anything in them. Whereas this router component here has stuff in it, like how you would put stuff inside of a div in HTML. You know, we never do that with feed or something. And so this is a special pattern that makes use of a reserved prop name called children. So in fact, if we go here, what we can see here is that I've created something called a card. And this is, oops, did I forget to update this one? Well, live updating to, sorry about this. I thought I fixed this. So if we turn this into a nice React component the way we've learned it, what we can do is we can see that this component is just taking whatever props we feed it, and it's saying, hey, I'm going to put that inside of a div. And just put whatever you give me. And now the interesting thing here is that when we actually use this card, we can actually just put things inside of it. And it doesn't have to just be one thing. We could put multiple things. But if you want to see how this looks, if we check out how the original looks, we can see here we have a dog generator. We can, if you want to see a dog, we can load a new dog. By default, it's loading Pembroke corgis. Someone name a dog breed that you want to see. Border collie. Is it IE? Yeah. Oh, they don't have border collies. So instead, we get this nice picture of Dan's son as an infant. How about a Labrador? So you see lots of good dogs, and we have this rating here that tells you the goodness of the dog. See, if we put in cat, the goodness goes down. But now instead, if we switch to this this other branch where we had this card component again, and now we're going to wrap our good boy meter in a card, and we're going to wrap this dog viewer in a card. And now if we reload the page, we can see now these are in a card. And in fact, if we want to put them in just one card instead of two, we can delete this other card and move this into one. So you can have an unlimited number of children if you'd like. And now you can see both the good boy meter and the dog are in the same card. So that's sort of the use case of the children prop. You can use it to make things like the reach router that we've been using in this class. You can use it to just wrap up anything where you want sort of nested behavior or something surrounding You can also use it to create what are known as higher order components, or in a sort of related sense. So if we take a look at some higher order components, we can see here that this is a slightly different but almost identical form. Instead of saying props.children here, we're actually saying props.contents. And this difference means that instead of passing in things to the card as something inside of the HTML tags between the start and end tag, we now pass it in as a prop. But the thing we're passing in as a prop is still HTML. So we're still passing in this sort of JSX syntax here, passing in good boy meter as contents. And this is nice if you want to like name the specific children that you're going to put inside the card. And if we look again, we can see that it's back to being two separate cards. Now, higher order components are sort of useful in the same way that these children props are. They can be really good for debugging as well, because now you have access to these components. You can modify their props, and you could, for instance, fetch some data. You could essentially, instead of this card component, or inside of this card component, we could have a use effect where we load something and then update the state. And then we could pass that state into this props.content in order to like help load some data. So that's one potential use case of higher order components. And in general, in anywhere where you feel like you might want to use inheritance, if you've gotten used to that from like 009 or 031, this is sort of a good use case for using higher order components. However, a lot of higher order components have been replaced by custom hooks in React. So we haven't really given you a good definition of what hooks are. And I'm still not, because hooks are a magical, mystical thing that are literally just functions. Hooks are functions. There's actually nothing mystical about them. The only thing that makes a hook is that it calls other hooks. So any function you write that has use state, use effect, or use anything and is not a component is a hook. And the purpose of this is really just to enable you to reuse some logic. So if I pull up an example here, let's take a look at the timer file here. So this timer is a hook, and you can see that because we've named it use timer, and we're using some state here. So what we're doing in this timer is we create a state called count, initialized to 0, and then we create an effect where we set an interval. If you're not familiar with this, you might remember it from one of the intro JavaScript lectures. Set interval is a function that allows you to create a timer that always repeats. So every however many milliseconds, so in this case, interval milliseconds, it's going to call this function again. And in this case, this function is going to take whatever the count was, and it's going to increment it by 1. And with this effect, finally, the use timer hook is going to return count. So every time we use this use timer, for instance, in app.js, now we're using use timer right here, passing in 1000. It's exactly as if we just copy pasted this code in here. And named this timer instead. It's exactly the same, and it just allows you to reuse this, because now if you wanted to use this use timer hook for any other timer related logic, you can use that instead of trying to like copy and paste the code or create a whole nother thing. So if we want to look at this example, we can see down in the bottom now, it's a little bit small. We can see that there's just a little counter that keeps going up once a second. And that's caused by this timer component. So hopefully that clears up the fact that hooks are not something mystical or mysterious. They're just functions. They're just ways to sort of modularize your code. So the same way you'd make any other function, you can just put your use state and use effect into a new function. There are a couple of rules, however. You have to make sure that the use state and use effect aren't inside any like if statements or for loops or anything like that, or like recursive functions. But otherwise, it's exactly the same. In addition to use state and use effect, there are some other built-in hooks that are that may be useful to you guys. This use context hook, it allows you to avoid passing data all the way through a component tree. So if you have 100 components deep in your React app, in Chatbook we had 3. It was just app, or 4. It was app, then Chatbook, then chat list, then single user. But imagine you had 100 there. It would be sort of annoying to pass all your information through every single component. And so to simplify things, you can use a context to sort of get whatever data you need in a simpler way. There's use callback and use memo, which allow you to avoid recomputing expensive functions or data. And use ref, which we'll actually look at in just 1 second, which allows you to keep mutable objects around and manipulate the DOM manually to do things like set scrolling. Another thing that we can do is use reducer, which helps you simplify and modularize logic. I think that works with Redux, if I recall correctly. I haven't actually used this one. And there's also use debug value, which allows you to add some data into the Chrome developer tools. However, there's also some things that we really, really ask you not to do in React. And the main one for this year, please, 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 sorry, I think this is getting cut off, but please don't use document.getElement by ID. Because technically it could work when you have a scenario like this. You have this input element, which, as a reminder, as a reminder, this input element is this one, where we can type in the name of a dog. And we want to be able to get the text of that input when we press this key down. So again, we could use document.getElement by ID. However, it's really not a good idea. The reasons are that IDs are unique, which means that your component is no longer reusable if you use an ID. And it also messes up a bunch of other React logic, and you have to be extremely careful even if you were to use it. So we recommend just completely cut it out. There's absolutely no need to use it. Instead, what we do is we use this event.target.value. In this case, because the event we're talking about is on key down of the input, that means event.target, or event tells you like what happened. It has all the information about the key press. Event.target tells you where it happened, so namely the input itself. And event.target.value now is the value of the input. So you can get the text there without having to use document.getElement by ID. However, what happens if the event target isn't the element you want? So maybe based on the input, you want to update some other text box or some button or something else. Well, in that case, we can use what are known as controlled components, where you synchronize the state of your React component with the value in your input elements. This makes sure that there's always a value you can read, and it makes sure to update the state to modify whenever you type something in that input. So if we take a look at another branch, we can see how this controlled component works. So here we have a new state called input, which is going to be the text that's contained in our input element. Interestingly, we're going to add this handle change method, which basically we're going to add this to the input element here. And whenever there's any change in the input element, we're going to set this input state to be equal to the data in the input element. And now this means that we have an exact copy of whatever we've typed whenever we want it. So we can use this however we want. So in this case, we could use it to say add some new info here. Let's say add some more text here. Current dog, and we'll type in the input. And so that'll show us the dog that we've currently typed. It'll just sort of echo it back to us. So if we say, as we type, every single change we make, you can see it's echoed here. And this is something that's sort of hard to do otherwise. I'll go back to labs. I like labs. Another thing to note about controlled components is this value in particular. So here in the input, we're passing the input state as the value of this input component. So this is sort of tricky. What we mean here is that at any given time, the value that we want to show up here in this input needs to be equal to whatever value we have in state here. So we both update the state based on the input element, and we update the input element based on the state. This also allows us to change the state whenever we want to. So if you notice, there's a clear input button here. And if I click it, I can just delete whatever text was in here. So controlled components are also a nice way to do that. And running a little over time, so I need to wrap up. But one more quick thing to note is how to use refs. So this is another way to handle if event.target isn't the element we want to edit. Instead, we can use what are known as refs. And we can use the useRef hook that we just mentioned. So in this case, what this hook does is it creates an object here that will always be the same, and it will allow us to store mutable data. So in the future, we'll be able to say ref.current. Initially, ref.current is just going to be set to null. However, by passing ref into the input here as a ref prop, this is another special prop, just like children. This allows us to, or this automatically sets ref.current equal to exactly this input element. This means that whenever we want to, we can just say ref.current.value. And notice I have a question mark here because at the beginning, ref.current is going to be null. And this allows me to access it only if ref.current is not null. And so, but I've combined this with the timer code. So whenever the timer updates, we're also going to see ref.current's value. And so if we look here, we can see that whenever I type, it gets copied down to the bottom of the page once a second. And this could be helpful for you in some of your own code in sort of more niche use cases. It's definitely something to be avoided if you can. With that, I think that's about all the time I have, but I want to really encourage you guys, if you haven't already, please, please, please download the Chrome or Firefox React developer tools. They really help us to help you to understand your code and to find bugs. So hopefully this lecture introduced you to some important use cases for React and some interesting patterns. And for that, I'll hand it over to our sponsors.